On Earth, the highest temperature ever recorded by humans is 56.7 degrees Celsius, but compared to the mantle at 3,000 degrees Celsius and the core at 5,500 degrees Celsius, human records are obviously insignificant. In the core of the Sun, 150 million kilometers from Earth, the temperature reaches 15 million degrees Celsius. And white dwarfs, born at the end of a star's life, with a core temperature of 100 million degrees Celsius. And neutron stars, also formed at the end of a star's life, with a core temperature as high as 1 billion degrees Celsius. But the temperatures of these celestial bodies are still far inferior to human intelligence. In the relativistic heavy ion collider, collisions occur when gold ions are accelerated to near light speed, temperatures reaching 4 trillion degrees Celsius. In the Large Hadron Collider at CERN, when physicists bombard atomic nuclei with high-energy protons, they can generate temperatures of 10 trillion degrees Celsius. However, at such temperatures, matter is no longer matter, but quark soup. In the foreseeable future, the record of 10 trillion degrees will undoubtedly be broken. Essentially, temperature. It reflects the intensity of thermal motion in microscopic particles. Therefore, the higher the energy of the particles, the more intense the thermal motion, the higher the macroscopic temperature exhibited. And except for photons, other particles have rest mass. Thus, they are all bound by special relativity and cannot reach the speed of light. But as they approach the speed of light, the kinetic energy of particles undoubtedly increases infinitely. Then, does this mean that temperature can also increase infinitely? According to current theories, when an object's temperature becomes high enough, the wavelength of their radiation will be smaller than the Planck length, thus losing physical meaning. Therefore, the Planck temperature corresponding to the Planck length is considered the upper limit of temperature in the current theoretical framework. Specifically, for 1032 degrees Celsius. At Planck temperature, quantum mechanics and general relativity both fail. Time and space also collapse. All particles cease to exist. The four fundamental forces unify into one force. According to the standard cosmological model, Planck temperature only occurred after the birth of the universe, in the first Planck time, briefly appearing once. That was also the first grand unification epoch of the universe, and many physicists, including Einstein, hope to recreate the Planck temperature. Because in this way, so that humanity can unravel the mystery of the universe's formation and evolution, and reunify the four fundamental forces, thus creating a unified field theory far surpassing relativity and quantum mechanics. But just as current theories, due to not being advanced enough and unable to describe the Big Bang singularity, similar to the black hole singularity, the current Planck temperature is merely the temperature limit of current theories, not the limit of temperature itself. In the universe, certainly, there are rules that humans have not yet discovered. And those undiscovered rules may allow temperatures exceeding Planck temperature, may allow temperatures to exist. But for the present stage, relying on relativity and quantum mechanics from over a century ago, for human civilization seeking to understand the universe. But those rules are too distant. After all, today's so-called high technology is rooted in theories from a century, or even theories from centuries ago.